How many engines do you know of that you can completely disassemble with one tool? A screwdriver. That's it on this engine. Now if everything, I actually did use one other tool. If everything was loose on it and was fit properly, I could have only used a screwdriver, but I had to end up using a puller. Got it mounted over here in the vise to pull off the little quasi pulley that was on there, so on the crank, and it was rusted pretty good. Got the crank straightened up fairly straight. I'm going to put it in a vise or in a lathe and polish it a little bit, clean it up, clean the shafts up a little bit on it. Got the lagging cover straightened up, dollied out the dents and cleaned it up a little bit. I'll clean it up some more before we put it on. I wanted to show you the cylinder. They've even gone to the trouble of putting some wood lagging in the cylinder here. I didn't remove it, no use to. I did replace that steel nipple that had plier marks and everything all over it with a brass nipple. That's a kind of a modern touch, but its serviceability is what I'm after. In case I ever have to take that out, I can get on that hex with a wrench, take that off, then I can just slip the lagging off of it and not have to unsolder it. So I just degreased everything. I'm going to work on the sliding surfaces. Still some surface rust in there. The base is clean, rusty but clean. Just used a solvent and degreased everything. And going to start working on the fracture on the rod here, and get it V'd out with a grinder and get ready to braze it. So keep working here. Okay, I'm with my assistant here, Ace, and my other assistant, Emma. Hi, Emma. She's helping me with the engine here today. And I wanted to show you what I've done here on this crack on this broken rod. I got to digging around on it with our little burr here on the end of the Dremel. And I wanted to eventually, or initially, V that out. So I ended up cutting and cutting and cutting, and all I could find in that crack was soft solder. So I finally took, it had been repaired before, so I finally took a torch and melted the solder out, and then cleaned it and V'd it some more, and now I've got a gap there that's too wide to braze. So what I've done is I've taken an ordinary piece of music wire and I did a little forging on the end of it here. I'd heat it up and hammer it into shape, and I come up with a little horseshoe shaped piece like this, and that piece will actually fit right inside that crack. I'm just going to put it in there quickly here for the sake of the video and show you. It'll be fit just a little bit better than that, and that will take up the space, and it will actually braze, and that joint will probably be stronger than the cast iron around it. So that is how we're going to attempt to fix this brake. So I'll have to take it up to my welding shop and set it up and braze that, and I'll get back with you later on how that turned out. Now the next thing is we swing around here to the lathe. Let me turn a light on here on the subject. I've got an indicator set up here, and I just wanted to show you how we indicate this particular setup. And it's within about 3/1000ths of being the same measurement as this side here. So, and we don't have any run out back here on this shaft to speak of. So I think we've got this tweaked pretty close, close enough for what it is. It's just going to be a slow running. I'm just going to tick it slowly, tick over. Not going to be any high speed, high load, anything like that. So I think we're good. If I have to address a further issue with it later, I will, but for now I'm just going to go ahead and finish polishing up the shaft, and we've got her trued up pretty well, and we're going to try to get on back together with it. So that's where we're at as of this point. So Emma, you ready to get back to work? Okay, we'll see you later. Okay, we're looking at the brazed repair here. You can actually see the steel repair in the center there. A little lighter color than the bronze. It's been brazed up and filed down, and looks pretty decent. Came out very well, so we'll continue on. I'm in the process of shimming the crank. I decided to use the bearings that came in the engine. They look pretty decent. They're original, and that's fine. They're in pretty good shape for being original. So I've made, to take up the most space, I've made some aluminum shims that fit on here, and then some thicker brass, and then some thin brass. This is 5/1000ths, and I'm finding out I need another piece of thick brass. This is 32/1000ths. I need to make another couple of those, so getting that taken care of. And let's see here, what else? Coming up with some set screws for the flywheel. I've got it set up here in the angle vise, and I've run an end mill down and created a flat for the set screw, and this is all done at an angle because that gives me clearance, one, to get the hole drilled in the little short hub here, which is no wider than the rim of the flywheel, and also gives me good access to get on the Allen grub screw with a wrench. And this is fairly common practice, putting the set screws in at an angle. This is a fairly low torque operation. All it does is provide inertia for the crankshaft. There's not actually anything being driven from the flywheel itself, so we can get by with a single small set screw. I want to drill it and tap it for 1032, and that should be sufficient. So I've got quite a mess going on here with parts and pieces and everything else, but we are progressing.